recording charms. I hope everyone is doing well today. And look at this picture. Oh, is it a motion? Okay, don't worry. That's what we are going to learn today. So we are back with an amazing rapid recap session on the topic called motion and time. So let's get started. So we will be having a wonderful session today. So please pay attention throughout the class. And my name is Aishwarya Sindhu Ramachandran and I will be a science educator today. So before getting into the main part of the session, let me tell you the basic tools available here. So we have an amazing comment box. If you find any kind of doubts in between, please don't hesitate to ask your doubts in the comment box. I will resolve it for you. And not only that, please have a notebook and a pen along with you so you can note down the important points as we are going to discuss multiple concepts today. So let's get started, and here we are going to start off with our basic contents. So what are the basic contents? Rest and motion, distance and displacement, speed and velocity, units and standardization, and finally types of motion. So let's continue with the very first topic. It's all about rest and motion. Oh my god, this is a very simple concept, okay? So let me break it down for you. And here you can see my friend Arun is back. Oh my god, Arun is back today. And I am extremely happy that Arun also has joined today because we are going to learn everything together. Okay, so do you know Arun is going to have a trip to Manali? And look at his position. This is his first position and this is supposed to be his second position. But even after the passage of time, there is no change in its position, right? Oh, so that means if there is no change in position with respect to time, it is termed as rest. And what about motion? The same example, this is his very first position and this is his second position. And with the passage of time, you can see that there is a position change from 1 to 2, correct? So that means if there is change in position with respect to time, then it is said to be motion. Now we are moving towards the next concept. It's all about distance. Oh, what does it mean by distance? Oh, so distance between Earth and Sun. What it is? We know that it's 1 AU, right? 1 astronomical unit. But what about this one? Delhi to Alleppey? We know the distance will be mentioned in kilometers, right? Yes. So this will be mentioned in kilometers. But what is this kilometer, AU and all? These are the units, right? Yes. So distance is nothing but the quantity which represents the length between 2 points. Got it? It is the path length between 2 points. But what we are going to learn now is all about the distance and displacement here. What is the basic difference between them? So let's imagine this is your classroom. Okay? And the class is so boring. Or if you don't like the subject, what do? You will just try to come out of the classroom. Correct? Or you say some excuses like need to go to washroom or toilet, right? Yes. But we know that there is a path to reach washroom so easily. So that's the line which is represented with dotted ones. Okay, so this is a path that has to be followed to reach washroom easily. But we know that we need to waste the time somehow because we are not interested in the class. So we need to escape out of the class, right? Yes. So what do? Instead of going directly to the washroom through this path, you will try to take some other paths to waste the time somehow. Correct? So that's what we are going to explain now. So instead of going directly to the washroom, what do? You try to come to store first. So let this be A. Okay? A is the path which connects classroom and store. Then from store to library. So this can be represented with B. Similarly, from library to washroom, it's going to be C. Okay, so we know that there is a direct path to reach a washroom, but we have to waste the time, so we have preferred these multiple paths to reach a washroom. Correct? So the direct path to reach a washroom can be named as D. Got it? So what I'm going to do, I'm going to differentiate them. Okay, so the first one is distance. So what is distance? It's nothing but the path length. Okay, so what is the path length here? Path length is represented by A plus B plus C. Because you need to reach a washroom somehow, right? But you are taking different paths for it. So we are going to add all the lengths together to get the distance. So I'm going to write distance is equal to A plus B plus C. Okay, but what is the shortest distance between washroom and the classroom? Is D, right? So the shortest distance is going to be the displacement. So all about the basic definitions of it. So path length is nothing but the distance and the SI unit is meter. Similarly, displacement is the shortest distance between 2 points. So SI unit is again meter. So now we are moving towards speed. So speed is a very important term that needs to be learned, okay? So you might have learned this term a lot of times or heard at least once in your life, right? So when you try to ride with your dad or mom, or when you bicycle, or when you try to have a trip from one place to another, you might have heard these terms a lot of times, to reduce the speed, to increase the speed, right? Yes. So what is the speed exactly? So this is a distance traveled in unit time. Oh, that's a new information, right? How long an object has traveled in a particular time duration can be called it as speed. So what is speed exactly? It is nothing but the distance covered by a body in a particular duration of time. So what is its formula? The formula is nothing but distance divided by time, and the SI unit is given by meter per second. And when you look at it, there are mainly two types of speed that we need to learn here. So the first one is average speed. Average speed is the total distance covered in total time. Got it? So whatever the total distance covered in a total time duration, this can be termed as average speed. But when it comes to the instantaneous speed, this is a different one. Speed of an object at a specific moment of time. So if I want to measure speed at this particular moment, that's going to be instantaneous speed. And this can be different or same throughout the journey. It's nothing but the speed at a particular moment. Clear? And now we are going to learn about odometer and speedometer. So what is meant by odometer? This is actually a device which can measure distance covered by a vehicle. Look at this. This is nothing but the reading which gives you an information regarding the distance covered by the body. So odometer measures distance covered by the vehicle. Similarly, when you talk about speedometer, speedometer which measures a vehicle's speed at a specific moment. That means what kind of speed it is? It's a very simple one, instantaneous speed. So speedometer measures instantaneous speed, not the average speed. Got it? And now we are going to talk about velocity. So what is velocity? Velocity is the displacement covered by the body in a unit time. So we know the basic differences between speed and velocity now, right? So speed is distance by time. Velocity is displacement divided by time. Got it? And what about the SI unit? SI unit is same, right? Meter per second. Is it a vector quantity or scalar quantity? Velocity has both direction and magnitude. So this is definitely going to be a vector quantity. So please write down this is a vector quantity as it is having both magnitude and direction. And now look at this one. It's all about the ancient methods of measurement. So these are known as non-standard units, because these units were different from one person to another. These were not standardized. So let's take some examples here. So feet, handspan, yard, cubit. If you take any of these, this can be different from one person to another. So this is not a standard unit at all. So what is meant by standardization and why is it so necessary? We know that non-standard units can be different from one person to another. Correct? So this is not a standard unit for sure. This cannot be used everywhere because this can be different from one person to another. But standardization is nothing but a way in which the units have improved in such a way that this can be used anywhere in the world. Okay, so let's take an example. So 1 meter equals 100 centimeter. So if you go to USA or Canada or New Zealand, wherever you go, you can find 1 meter as 100 centimeter itself. Right? So this is going to be a standard unit because this cannot be changed from one person to another. Anywhere in this world, the 1 meter is going to be same as 1 meter itself. It consists of 100 centimeter. So this is a standard unit. So that is where the standardization is very much important. Hope you're clear with the point. And now we are moving towards next one. It's all about types of motion. And what about the first one? It's nothing but the rectilinear motion. If the body moves in a straight line, it is said to be rectilinear motion. And what about the second one? Circular motion. So in circular motion, the body moves along the circumference of a circle. You can see that the car is moving along the circumference of the circle. And similarly, when you talk about periodic motion, it's nothing but the motion that gets repeated after regular intervals of time. You see it? This will get repeated after regular intervals of time. Therefore, this can be periodic in nature. And now we are going to learn combined motion. So what is meant by combined motion? If a body has more than one motion at a time, this is said to be combined motion. So let's take an example of a pendulum here. So we know that this gets periodically done, right? It has a periodic motion. The motion gets repeated after regular intervals of time. but at the same time it is also oscillating, right? So oscillatory motion also occurs. So to and fro motion of an object from its mean position can be called it as oscillatory motion. So this is the mean position. So from here to here it goes, from here to here it comes, then it goes back to B position and come back to the mean position. Clear? So this is how the motion occurs. So to and fro motion is considered to be oscillatory. Similarly, at the same time, a periodic motion which gets repeated after regular intervals also happens here. And that is what the reason we consider this one as a combined motion. And now we are going to learn uniform and non-uniform motion. What is the first one? Uniform motion. So what is meant by uniform motion? When a body covers equal distances in equal intervals of time, the body is said to be in uniform motion. Oh, what is that? Let me explain for you. So the first part is nothing but taking the time intervals. So we have taken similar or equal intervals of time here. Everywhere it's 2 seconds, right? So in every 2 seconds it covers the same distances. Look at it. 3 meters. In the first 2 seconds it covered 3 meters. In the second 2 seconds it covered 3 meters. And in the third 2 seconds also it's covered 3 meters. And similarly, you can see that if the body covers equal distances in equal intervals of time, does it make any kind of change in speed? No, right? And that is what the reason the body moves with a constant speed here. Clear? Similarly, when it comes to the part of non-uniform motion, the body covers unequal distances in equal intervals of time. The time intervals are same, but it covers unequal distances here. So look at it. In the first 2 seconds, it's covered 1 meter. In the second 2 seconds, it covered 2.5 meter. In the third 2 seconds, it covered 3 meters. So that means the distances are differing here. Correct? So the distance covered by the body is getting different here. That means, does it follow constant speed? No. So the body is going to move with a variable speed, and that is why we call it as a non-uniform motion. Clear? And I hope everyone is clear. And now we are moving towards the summary part. So we have covered rest and motion, distance and displacement, speed and velocity, units and standardization, and finally types of motion. And that's the end of the class, and I hope everyone really liked the session today. And we'll see you next class with an amazing rapid recap session similar to this. So have a nice day and goodbye everyone. Thank you so much.